Okay, here we've got the last question on the paper. It's a multi-parter, and these late questions on Core 3 papers, you kind of know all the parts are going to fit together, but you don't quite know how. Take each one on its merits as a separate challenge to begin with. So the first one, we've got to use a quotient rule on sine theta over cos theta and get to the answer sec squared theta. I think you've got this very example in your notes. So don't be intimidated by the fact it's the last question. Set up your u, set up your v, use the quotient rule properly, and you know what you want it to simplify to. Don't rush that. Try and get there convincingly without making any algebraic slips. Part B, of course, is a re-entry point. We now need to show that these two things are equal, and since we've got what x equals, and since we've got the complicated side of the expression, the way to tackle that is to start with this and what x equals, substitute your sine theta in everywhere for x, and once again try to be convincing, but you know where you want to head, so you want to get to tan theta. Okay. Then part C is an integration by substitution. It's one of these backwards ones where x is actually the subject of the formula, but as with any integration by substitution, start with your substitution x equals sine of theta, differentiate that, do something by do something equals your derivative, and you want to go as far as what dx can be replaced by in your integral. Okay, so that will give you instructions about what this dx is going to become. The 1 minus x squared, x we know is sine theta, so we've got 1 minus that squared, which came up here as well. You are going to have to remember what 1 minus sine of theta squared is. It's a Core 2 identity, so make sure that you're fully conversant with that. It was from chapter 2 of Core 3 as well. And so therefore this integral will turn into 1 over something to the power 3 over 2 times whatever you had for dx, which will be something d theta. And then you need to simplify this. Now inside this power 3 over 2ness, you've got a power expression there. You should have something squared in here. And then you've got to remember how to combine two powers. When you've got x to the power p in a bracket to the power q from Core 2, you should know that that's x to the power pq. So the power inside and the power outside here get multiplied to work out what's going on. So you need to use that, you need to use the fact you've got something on the top here, and there's some cancelling that happens. So when you do that carefully, what you're aiming towards is the integral of just 1 over, it'll be something squared, d theta, where this is in terms of theta. And 1 over a trig function has got a special name, and 1 over a squared trig function is going to be not a million miles away from sec squared theta. So if you can simplify this integral to something that we've seen before, that we know something that differentiates to, that's why part A is in there. It's to help you with this simplified integral once you get there. So you should be able to write down the answer to that in terms of theta, but look, they want the answer in terms of x. So having decided that you're integrating something you've seen before into an expression that they've shown you, we then have the task of expressing this theta expression in terms of x's. But of course sine theta over cos theta is tan theta, and part B was all about getting an equivalent to tan theta in terms of x's. So part B was in there simply in order to turn the answer to this, which will be a simple function of theta, into a more complicated expression involving x's that they've already shown you.